Screen is visible. Hello, is it audible?
Yes, sir.
Okay. So in the previous class, we have already discussed about 2 times. We have discussed this 2 wattmeter methods and 3 wattmeter methods. The power measurement by using 2 wattmeter method for the balanced bridge. We have discussed the theory part here, and we have already done the practical also for the balanced and for unbalanced condition, both the condition, and it is for the delta connection, and this one is for the star connection also. So the next instrument that is called Megger. This one also we have already discussed in the practical. This practical is over, no? Already Megger. The first experiment itself we have discussed. Then also I will once again I will take the theory part of this one here now. So the Megger is the instrument uses for the measurement of resistance here. So the unit of resistance is ohm. So Megger is nothing but mega ohm or mega resistances. We are going to measure that one. For that reason, the name came here Megger. For the high resistance value measurement, we are going to use this type of instrument here. Okay, the Megger is the instrument. We are going to use this measuring instrument for the measurement of resistance of insulation. Insulation and conduction. Do you know the meaning of insulation and conduction?
Yes, sir.
Insulation means which opposes the flow of current. It will not create a path to flow the current. But the conduction, it is going to create a path for the flow of current. So where we know the characteristics of resistance is inversely proportional to the current. Yes, if the resistance increases, then current will be decreases. It will not. So the insulation will not allow the current to flow, means it has high resistance here. The insulating materials or insulators, they are having very high currents they were having. For that reason, so the Megger is going to measure the insulation resistance we are going to measure here now. And it works on the principle of comparison here. That is nothing but the resistance of the insulation is compared with the known value of resistance. We are going to use some known value. That resistance value, it is going to compare over there. How much it is there? We know that on the plastic, how much the resistance will be already in the laboratory. They have, while doing the, suppose in the conductor, they are going to design and they are manufacturing, means they know that one, how much current it can carry. After that one, what will happen? The temperature increase means what will happen? Everything it is going to count on that one here. Is it audible? Audible?
Yes, sir.
Problem okay. If the resistance of insulation is high, the resistance of the insulation is high, then the pointer will move deflects towards the infinity. We are going to, if for the high resistance means it will deflect towards the infinity. It has two ends are there here, like this. One side it is infinity is there, another side it is 0 is there. For the high resistance, it is going to indicate towards the infinity side. For the lower value of resistance, it is going to indicate towards 0, like this here. If it is middle, then it has not 0, not infinity, medium resistances it is having, like that we can consider here. Some people, they are joining now. Okay, so it deflects towards infinity, and if it is low, then the pointer indicates 0 resistance here. If the resistance is low, then the pointer will indicate, so it has low resistance means 0 resistance. High resistance means up to the infinity, the high it may be there. So why we have to study this experiment means this instrument, its accuracy is very high as compared to the other instruments. See, you can visit any transformer companies, you can visit, before doing manufacturing that one, they will do the winding of the transformer first. Once the winding is over, then they are going to calculate the Megger of that point. Megger they are going to calculate. After assembling that into the tank and filling the oil, then they are going to heat up that one, then they are going to check the Megger resistance, they are going to check over there. If it is showing infinity, then they are going to send over there. So like that, the accuracy of this instrument is very high as compared to other instrument. Based on that, we are going to use this one here now, this instrument here. See here, this is the diagram of the Megger here now. The diagram of Megger here now. It consists of current coil and voltage coils. It is consisted. Actually, this is the PMMC instrument only. See here permanent magnet is there. This one and this one here now. Two permanent magnets are there. In between these permanent magnets, one moving coil we have placed here now. That moving coil is nothing but current coil. We are going to call that one. This is the current coil. Here we are using to give the supply here now. We are using a hand generator DC supply we are using here now. In between here also the permanent magnet is there. The hand driven, whatever the mechanical energy we are applying by hand only here now. By applying by hand, we are applying this one here now. It will give the supply to this PMMC instrument here. All of you have studied the PMMC instrument already. The permanent magnet moving coil instrument here. Now, whenever the supply we are going to give here, in between already the permanent magnet is there. Whenever the supply will pass through this one here, then it is going to rotate here now, which is connected on the shaft here now. Spindle we are going to call that one. The spindle, it is connected here now. And we are using two voltage coils we are using here now, V1 and V2 here now. Whenever this coil is outside this magnetic field, here the permanent magnet is there, V2 is outside, it is not linked to this coil here now. So on that situation, the torque developed is very less, and we can say that one here now, if the resistance is very high here now, all the current will flow through here only, then it will indicate the infinity here now. It is lower magnetic field we are going to call, weak magnetic field. Whenever this V2 coil, voltage coil, is outside this in between the magnetic field, then the weaker magnetic field is there. We can say that the resistance of this one is infinity here now. If it is infinity, we are giving the supply here now, positive supply we are giving here now. If the resistance is high, means it is not going to allow the current to flow here now. It will block the current here only. The high resistance is there. Then what will happen? Here the current will flow through this one, and it will flow through the negative here. It will flow through the negative. That is, it is in the weak magnetic field we are going to call here now. If we have provided some resistance here now, less resistance here now, then what will happen? By doing the hand driven generator, by operating this one, the supply will start to flow through this one here now. Here we have used some selector switches we have used here. Selector switches we have used here now. 1:10, the resistance value is multiplying into this one, and it is connected to the spring methods also here now. Whenever, I will just a minute. Hello. See here the springs we are using here now. The springs we are going to use here now. Whenever the resistance is zero, the unknown resistance, whatever we are using here now, that is zero is there. On that situation, these springs are there. It is going to compress over there. It is going to compress over there. The pointer will start to come towards zero here now. Then when the spindle is start rotating, this V2 will comes into the strong magnetic field here now. Inside this, in between this magnetic field, it is going to come. So the resistance is 0, then the V2 will be in strong magnetic field and the spring is compressed over there. And if the resistance is very high, then what will happen? All the currents will flow through this one here. Now the V2 coil is in outside this magnetic field or in weaker magnetic field. The springs are stiff over there, they are not compressed or they are released over there, and the pointer position will be at infinity here. The pointer position will be at infinity, we are going to call that. So this is the operation here. Now with explanation, without the diagrams, these two are the permanent magnet. Here also permanent magnet is there. So same magnet we have used for the generator as well as the permanent magnet for the moving coil instrument here. Now the coil is current coil we are using here. Now this is the pole shoe we are using. The pointer or free calibrated scale is there. One end is infinity, another end is it audible? Okay, another end is 0 is there here. Now the selectors which we can select the voltage range here now by based on this resistance, varying this resistance into 10, into 100, into 1 also we can use the selector switch also. So one by one here, this is the simple operation, very simple operation is there here now. So we'll start by reading point wise also. Can whatever I have explained, same thing we have written here now. The Megger has one current coil, two voltage coils, that is V1 and V2 here now. This is the current coil we are using. This one V1 and this is V2 we are using here now. V1 and V2, two voltage coils are there. So voltage coil V1 is passed over the magnet connected to the generator here now. V1 is passed over that one here. V1 is passed over to the magnet connected to the generator here. When the pointer of the PMMC instrument, see here, this is the PMMC permanent magnet. The coil is moving coil is there here now. For that reason, moving coil we are using here now. And the pointer of the permanent magnet moving coil instrument deflects towards infinity. Towards infinity, it means that the voltage coil remains in the weak magnetic field and thus experiences the very little torque over there. It means that weak magnetic field is there, the torque produced is very low here, so the pointer indicates that it is at the infinity side only. If it is infinity side, it is the V2 or voltage coils are in the weak magnetic field. Weak magnetic field means the torque produced is very low, so that is infinity, we are going to call that one here. Rule number 34. The torque experienced by the coil increases when this pointer it starts to move towards 0. Then the torque increases. Torque experienced by coil increases when it moves inside the strong magnetic field or towards 0 here. No, the coil experiences the maximum torque under the pole faces and pointer set at 0 end of the resistance scale. So for improving this torque only, we are going to use the voltage coil V2 is used here now. The coil V2 is so allocated that when the pointer deflects from infinity to 0, coil moves into stronger magnetic field. Whenever the pointer start to deflect here now, this coil, it will comes under this magnetic field and it will produce the more torque to rotate this pointer or this coil here now, moving coil over there. For improving the torque, to improve the torque, we are going to use the coil V2 here. In Megger, the combined action of both voltage coils V1 and V2 are considered here. We are not considering only V2, only we are considering here now. Both are connected together. Then here V1 and V2 are both are connected together. We are going to consider both the combined action for the voltage coil V1 and V2 are considered here now. The coil comprises the spring of variable stiffness here now. Here we are also using the spring we are going to use here now, which is connected to the ligaments are there here now. Both the ligaments are connected. The spring stiffness here now, variable stiffness here now, it is stiff near to 0 end. Whenever the pointer is come to 0 end, it is stiff, and whenever the coils becomes go to the infinity side, it will become very weak over there. It is stiff near the 0 end of the coil and becomes very weak near the infinity end of the spring over there. Near the infinity end is there. See here, the spring compresses the low resistance portions and opens the high resistance of the spring over there. It is compresses for the lower resistance value and opens for the higher resistance value. Based on that, this V1 and V2 will be in the strong magnetic field and low magnetic field or weak magnetic field. They are going to move over there. Okay. Why these people are signing late? It is disturbing for us also. In between they will join. So the instrument has voltage selector switches over there. I told into 1, into 10, it is there. We are going to select a switch we are going to use, which is used for the selecting the voltage range of the instrument. The voltage range is controlled by selecting the varying resistance connected in series with the current coil. So product of current and voltage resistance, it is going to give the voltage only. So based on the selector switch, we can increase the range of current. Based on that, we can select the voltage range here. The voltage is generated by connecting the hand-driven generator here now. The last they have explained here now. This voltage is given by a hand-driven generator here now. By the shaft they have given provided here, and based on that, we are going to provide the display here now. I don't know how many of you were present for the Megger practical. I think it is there here only. Just if it is there, once again I will show the Megger instrument also. This one only. See here, it is a hand-driven generator here now. This part is there. Whatever this one, it is going to by driven this one hand generator. In between this magnetic field we have placed here now. This one and the pointer also they have given here now. It is not visible, na? Which be visible nahi na? Background.
Yes, sir.
Background की वजह से visible नहीं है वो. Virtual background I have used it for that reason. Here is visible. At infinity side only it is there first. Starting the pointer will be at infinity side. Whenever we'll connect some voltage, some short circuit, we will do that one. It will comes to the lower side, strong magnetic field, and it will connect to the zero side. It is going to come over there. So the test voltages usually 500 volts, 1000 volts, 2500 volts are generated by using a hand cranked generator here now. By using hard or hand cranked generator, by can generate 500 volt, 2000 and 1000 volts also here now. A centrifugal clutch is incorporated in the generator driven mechanism. Actually it is not there, but in the generator mechanism they have telling that one the clutch they are going to use, which will define the slips at predetermined speed. Whatever I have shown this one, it has the 400 RPM speed is there. Okay, so that constant voltage is to be applied to the insulation under the test here. Under the test, if we have used the clutch means constant speed and constant voltage, we can provide that one here now. This voltage provides test on strength of low voltage insulation as well as a measure of its insulation resistance, since it's sufficient to cause the breakdown at faults here now. So whatever the voltage we are going to provide here now, the slip we are going to provide here now, that will strengthen the low voltage insulation and also it is going to help to measure the insulation, and it will not cause the breakdown further at faults over there. So the breakdowns are indicated by sudden motion of pointer off scale at 0 end here. If any breakdowns or faults occurs over there, the pointer will deflect to the off scale or at 0 end, it is going to show that one. As the same magnet system supplies magnetic fields for both instrument and generator here. Whatever the magnets we are using here. No, this magnet, permanent magnet, we are using for both generator as well as for the instrument we are going to use here now. So generator, instrument and generator, and as current and voltage coils move in a common magnetic field. The magnetic field is same only here, no common magnetic field is there. So current coil and voltage coil both will move in a common magnetic field. So the instrument indications are independent of them, strength of the magnet here, independent of the strength of that magnet here. Whatever the instrument indications are there, whatever the this infinity as well as that just a minute, Vodafone all branches. Okay, so infinity and zero indications are there. They are independent of that strength of the magnet they are going to call here, no, based on the current flowing through the circuit and based on the spring and stiffness and based on that voltage coil, say they are in a strong magnetic field or low magnetic field or weak magnetic field. Based on that, the Meggers are used over there. So it completes the Megger, which one we are going to use in a industry, especially for the insulation test only we are going to use over there. So it completes the Megger part. The next instrument is there, that is called OhmMeter is there. It is from this instrument also we are going to measure the ohm. Ohm means what is the unit of which parameter unit is this ohm? Resistance here only. So here also we are going to measure the ohm only. Here also we are going to measure the resistance only here now. So an ohmmeter is an instrument used to measure the resistance and check the continuity of electrical circuits. See here, if the conductor is, अब suppose आपके घर में एक स्विच से एक लैंप हो गया है, वो बीच में किधर तो कट हो गई, तो कैसे मालूम हो जाता है आपको? If the lamp is not going to, whenever I will switch on the button, it is not going to run. It is not going to on properly. On that condition, what will happen? For each lamp or any load, two conductors are there. Okay, in that two conductors, which one is damaged? How you are going to identify? Both this end and that end, we have to join and we have to check that one, the continuity is there or not, by generating a pulse of voltage here. Now from here to there, current is passing through or not, and from another end, other conductor also is I have to check. If it is not continuity is not correct, then we can say that one in between it is act as an open circuit. Simple open circuit and short circuit test only we are going to do here. So an ohmmeter is an instrument used to measure resistance and check the continuity of electrical circuits and components here. Any component circuits and whatever the cables are there, we are going to check the continuity here. This resistance reading is indicated through a meter movement. Here also we are using a meter is there. Based on that movement of that instrument only, we are going to identify in that one here. So the ohmmeter must then have an internal source of voltage to create the necessary current to operate them. The ohmmeter, it should have to create some internal current or voltage source only. Then only we are going to pass the current in that particular circuit here now. From one end to another end, we are going to pass the circuit signal, voltage signal or current source signal we are going to pass. From one end to another end, if it is reached, then we can say that one it is continuum. It is continuum. Otherwise, we can tell that one it is open, somewhere the faults are there. So for that reason only, the ohmmeter must then have an internal source of voltage to create the necessary current to operate the movement here. And also have appropriate ranging resistors to allow desired current to flow through the movement at any given resistance here. It should have some ranging resistors which will allow the current, whatever the desired current we are going to flow, that one, it should have to allow that current here. Now based on that movement at any given resistance, it should have to operate that. So based on these criteria or conditions here now, the ohmmeters are classified into two types here. Based on how we are going to connect the meter, based on that, we are going to use two types of circuits we have designed here now. Two types of schemes are used to design an ohm meter here now. One is series type, another one is shunt type here. Two we are going to use here. The series type ohm meter is used for the measuring relatively high values of resistance, while the shunt type is used for the measuring the low values of the resistance we are going to use. Series type ohm meter we are going to use for the high value of resistance measurement, and while the shunt type we are going to use the low value of the resistance here. So one by one we'll discuss here. See here now. In this figure, we are going to consider that is called series type ohm meter is that here now. Series type ohm meter. Just a minute. बोलो मैडम पांच का क्लास है मेरा See here, this is the series type ohm meters we are going to discuss here now. See the figure here now. Here in series we have connected meter here now. One meter we have connected here now, that is called ammeter. We are going to call that one here. The current we are going to get here now. And here the unknown resistance we have connected here now. The unknown resistance, that is called Rx, we have connected here now. In this figure, the R1 is the current limiting. To limit the current, how much current it should have to pass. Based on that, we are using a current limiting resistance, that is called R1 is there. Roll number 4, R1 is there. And R2 is zero adjust resistor here now. If it is open circuit, then maximum current will flow through here only. On that condition, it should have to get the full current over there here now. For that reason, it is adjust to zero resistor here now. It is, we can variable resistance we can use here now. We can make this resistance as zero also here. You can maximum and minimum also you can make this one here. And Rx is the unknown resistor, and E is the internal battery voltage we are going to use here now. Rm is the internal resistance of the this bridge, that is called D'Arsonval bridge we are going to call here now. D'Arsonval bridge we are, or moment we can call here now. See here at terminal A and B we have connected the unknown resistance here. We have connected a unknown resistance here. Terminal of the ohm meter across which an unknown resistance is connected. Rm is the meter resistance, R2 is zero adjuster resistance here. Now you can adjust zero, you can adjust maximum here. No, and R1 is to limit the current here. No, E is the battery supply, Rx is the unknown resistance. So this is the basic circuit elements I told here. We'll start here now. Suppose we'll start the flow here now. Suppose this unknown resistance is zero is there here. I will tell that one, this unknown resistance is zero here. What will happen? The current will flow, start to flow here now. The current will start to flow. This one here, it will flow. If the resistance is zero, then the current will flow or it will blocks here only.
No.
It will flow. If there is no resistance at all, means it acts as a short circuit here now. The resistance is zero, means it acts as a short circuit. So maximum current will flow here only. So on that situation, this resistance, what it will do, it will set into maximum here now. R2 it is going to shift into maximum. So no current will flow here. all the current, the maximum current will flow through this meter only. This maximum, this ammeter, it shows that I equal to I max here. Now it is going to show that one I equal to I max here. No, if this meter is I max, then the current is the whatever the unknown resistance is there, that is called 0. We are going to tell that one. If it is maximum, then the current will be 0 here. Now then the current will be 0 here. Now this is the one condition. If the resistance is 0, then it acts as a short circuit, then the current, the I is I max here. Now maximum current it is going to flow here. Is it clear? First condition. The second condition, if R max is infinity here. Now if R max, Rx is the unknown resistance is infinity here. Now if infinity, it is going to block the current here. It is going to block the current here. No, and that condition, what will happen, the current, it will try to flow here, but because of this block, it will act as an open circuit here. No, so no current will flow. And that condition, what we have to do, we have to get this, all the currents we have to take here only. So this we are going to set as 0 here. No, so maximum current we are going to carry here only instead of this meter. Instead of this meter, the all the current we can give the bypass here. No, it can be, if this one resistance is 0, then all the current will flow here only because it has some resistance here. No, Rm is there here. No, so no current will flow through the current here. No, so I equal to, on that condition, I minimum are 0 here. No, if this meter is maximum, then resistance is 0, unknown resistance is 0. If this meter is minimum or reads 0, on that situation, the unknown resistance is maximum. Unknown resistance is maximum here. The same thing we have written here in this condition here. When Rx equal to 0, Rx equal to 0, the circuit we are going to call that one as short circuit. I will take that one just a minute. With the explanation आपको किया ना, easy हो जाते हैं. Just a minute. Circuit के साथ I will read that one. Okay, it is. See here, when Rx equal to 0, this Rx is there, the unknown resistance, it is 0 here. Now it is 0. On that condition, what will happen, if there is resistance, there is no resistance, means it acts as a short circuit only here. So R2 is adjusted to get full scale current through the movement here. Now, so on that situation, I will adjust this one into maximum here. Now, so no current will flow, all the current will flow through this one only. So it will adjust, R2 is going to adjust here now, and it will get the full scale current through the movement only. This is the movement is there here now, so full scale current it is going to get over there. Then I equal to IFSD is nothing but I equal to IFSD is nothing but full scale deflection here now, current at full scale deflection here now. So the pointer will be deflected to its maximum position on the scale. The pointer is for the resistance, just a minute. For the R0, Rx equal to 0, Rx equal to 0, the pointer will be, I will be maximum over there. It is going to reverse, it is going to detect over there. That I is max here. Okay. So deflected to its maximum position on the scale. Therefore, this full scale current is reading is marked as 0 ohms. If the full scale current is deflected, then we can consider that one, the resistance is 0 here now. The resistance is 0. Suppose instead of this 0, if this Rx is infinity, if this Rx is infinity, infinity means the resistance is maximum, then current will be 0. It acts as an open circuit here. If Rx is infinity, then it acts as an open circuit here. No, then current flowing through this I will be 0 here. No, because this 0 setter, it is adjust that one, it will also set into 0 here. Then what will happen? Maximum current will flow here and it will blocks over there only. It is going to block over here only because it is going to open circuit here. No current will flow through this meter here. No, on that condition Rx equal to maximum or infinity, on that condition the meter is deflect as minimum or 0 here. So I equal to 0, it is going to deflect 0 here. So the current I, it is deflected current is 0. The pointer will read 0. Therefore, 0 current reading is marked as infinity ohms here. If the current is 0, then resistance is infinity. If the resistance is infinity, then current is maximum over there. So by connecting different values of Rx, intermediate values are also marked over there. So the overall accuracy of the scale marking depends upon the repeating the accuracy of the movement and tolerance of the resistance used for the calibration we are going to use over there. So only two conditions why we are considering. See here, if this conductor is there, this is one conductor, from one end to another end I will pass the current, from either se either current aa gaya na, this one we can consider that one, the resistance is 0 here. The resistance is 0 of this conductor. If either say one end to another one, if the current is not getting here, no, so it acts as beech mein cut ho gaya kidhar to consider karne ka, so the resistance is maximum we have to consider. So for the series circuit, if the resistance is 0, then current getting is maximum. If the meter maximum detect ho gaye, then we have to consider that one as resistance is 0. If resistance is maximum, then current is showing 0, then we can consider as the resistance is infinity. We have to consider. Any doubts here? If you have any doubts?
No, sir.
Are you sure?
Yes, sir.
Can I go for the next? Proceed for the next slide then?
Yes, sir.
Very simple. Later I will ask the questions based on this. If the current deflection is full deflection, then what is the value of resistance, unknown resistance? If the current is deflecting full, then what is the value of resistance?
0.
0. If current is 0, then what is the value of current resistance?
Infinity.
Infinity here, no, or maximum we can call that one here. Okay, resistance is infinity. Very good. So that one we have discussed about the series type ohmmeter. Now we'll go for the shunt type ohmmeter. Shunt type ohmmeter, what we have done here now, the meter is connected in parallel with the battery supply, and some meter resistance also we have connected here now, that is zero adjuster battery resistance, and one unknown resistance is also connected in parallel with the meter here now, or supply here now. See, figure shows the basic circuit of the shunt type ohmmeter where the movement mechanism is connected parallel to the unknown resistance here. This is the movement mechanism which is connected in parallel with the unknown resistance here. In this circuit, it is necessary to use the switch, otherwise current will always flow in the movement mechanism. We are going to use the switch, otherwise what will happen? This is the nearest path, it is going to rotate like this only. It is going to, here only it is going to rotate the path here. So resistor RSHS is used to bypass the excess current here now. Whatever the rated current we are going to use here now, excess current is there. To bypass that one, we are going to use one extra resistance we have used. We have created, that is RSH path we have created here. We have created a excess current to bypass that one here. Now, Again, we will consider here now. Let us consider that when it is switch will be closed here now. This switch is closed. I'll consider here now. When Rx equal to 0 here now. So Rx equal to 0 means it act as a short circuit again here now. Rx equal to 0. Rx equal to 0. Then it will act as a short circuit here now. Next, the pointer reads 0 deflection or full deflection. I will set that one Rx equal to 0. Then this current limiting resistance is there variable to get the full deflection here now. The current will start to flow here now. It will start to flow in the meter and some current will start to flow in the here now. So, but here some opposition is there. Here also some resistance is there. Here also opposition is there. Is there any opposition here? There is resistance is 0 here now. So what will happen? All the currents will flow here only. All the currents will flow here only. So the meter is the deflects, that is called 0 here, because it is a clear path is there here. It is a clear path is there. So the meter, no current will flow through the meter because here Rm is there, here RSH is there, here the resistance is 0 here. The resistance is 0. So all the current will flow through this resistance only, and the meter will deflect 0 for the 0 resistance. If the unknown resistance is 0, then the meter will also deflect 0 here. Now the pointer reads 0 because full current flows through the Rx only here. No current flows through the meter and RSH. There is opposition, means which current will flow here? No, it will not allow here. No, all the currents, there is no opposition at all. All the current it will flow here. It will flow here only. Yes. Roll number 4, roll number 20. Already joined. Okay. Okay. So next one, another condition. I have one condition is that if resistance is 0, if Rx is 0, then current will be 0 here. Current will be 0 here now. I will erase this all the things. Next, second condition I will use here now. The second condition is that again I will consider as the switch is closed here now. The switch is closed. The Rx is infinity here. Rx is infinity here now. So the current flowing through this one, it acts as an open circuit now. It acts as a open circuit. Then the current flowing through this unknown resistance is 0. Whatever the current is there, maximum it will flow here. If the excess is there, the excess current will flow here. So if the resistance is infinity, then full scale deflection will be, current will be there for this meter here now. When Rx is 0, sorry, Rx is infinity, on that condition, the circuit acts as an open circuit. No current flows through Rx here now. The current, no current will flow through the Rx. So resistor R1 is adjusted to that full scale deflection here now. This R1 is adjusted, that variable is there to get the full scale through the meter here now. Therefore, maximum current reading marked as infinity ohms here. So if Rx equal to infinity, then the current is maximum, we are going to call here. The current is maximum here. So this is the operation of the sent ohm meter here, sent type ohm meter here. Is it clear?
Yes, sir.
Yes, sir.
See, one more question I will ask that one. If I will remove these all the things. Now for the same circuit, you tell me that, you tell me the answer. If Rx equal to 0 for the same circuit, what is the value of current?
0.
0. Yes. Okay, 0. I will tell that. If Rx equal to infinity, what is the value of current?
Maximum.
Maximum or 0. For this circuit, you consider this circuit. Check the circuit carefully.
Maximum.
Check the circuit carefully. Maximum, are you sure? I will tell that one 0. How it is maximum, you tell me. You are telling maximum, but I am saying max 0 here. I am saying 0 means, can you observe this switch? What is the position of this switch now?
Open circuit.
Open.
For the open circuit, is there any current flow?
No.
First, what we have to do for the closed switch condition, you have to operate. You have to close here now. Then it is maximum is current. If it is open, then you have to consider as 0 only. So same thing I have told here now. If Rx equal to 0, current will be 0 by closing this switch. And if Rx is infinity, the current is maximum here now. So for the shunt and series, there is much difference is there. Can you tell me now? I will take one here now. Just a minute. I will take the whiteboard here now. Here only I will take that one. For the, if Rx equal to 0 and infinity, I will consider here now. This is for the series type, and the shunt type, SH I will use. What is the value of current here now? Tell me here now. For the series, if Rx equal to 0, what is the current? Maximum. And for the shunt, if Rx equal to 0, the current will also 0. For the series type ohmmeter, if resistance is infinity, then what is the value of current here now?
0.
0. Then what about the shunt type ohmmeter? Maximum here now. So this table you have to remember, one marks questions will come over there. So based on that, you have to give the answer here now. You have to remember this table, you can practice it, and you can remember this table also. Okay. So for the Rx, for the shunt type, series type, what is the value and how it is going to operate, you can use that one here. So it completes the ohmmeter and Meggers. We have completed that one, and in the next class we are going to discuss the earth tester and all the things we are going to discuss. Earth tester is there, so many equipments are there. Single phase electrodynamometer, 3-phase electrodynamometer, moving iron type power factor instrument. Still so many components are there. We'll discuss in the next class here. If you have any doubts in this ohmmeter, you can ask now. किसी का कुछ doubt है? If you have any doubts, you can ask. Roll number 1. Seven, 11, 15, 17, 19, 21, 25, 27, 29, 31, 36, 37. So these are the absent roll numbers are, I will tell, 1, 7, 11, 15, 17, 19, 21, 25, 27, 29, 31, 36, 37. These are the absent numbers. टॉपिक क्लियर हो रहे हैं ना? एनी डाउट्स? कुछ समझ में नहीं आया ऐसा कोई है क्या?
नो सर.
No, sir.
सबको समझ में आ रहा है? Already have studied this subject. You concentrate. Don't miss the class. Okay. So I will end here only and we'll continue in the next class.